Okay, problem number 26. It's a question from the 2023 Berkeley Math Tournament. Let's just look at the footnote. The Berkeley Math Tournament, it's designed for high school students and also middle school students, depending on their level of achievement. Certainly they, for something like this, they would certainly need to know calculus. I see this as a difficult problem, by the way. And I'm often surprised that some people can go through these things quite quickly with little to no thought. So let's take a look at it. And the first thing I'd recommend for you to do over here is a U substitution. Right, so let me write this down. I'm going to say U equals, well, actually I'm going to say X equals e to the U. Let me get my eraser out. And let me just erase that and start again. So I'm going to say X equals e to the U. And then dx would equal e to the u du. All right, so what I'm going to do is try to get that integral so it looks a little bit easier to deal with. So looking at it, let's take a look. Let's see, I'd start off, in the land of x is e to the minus 1, so the u would have to be minus 1. And again, the reason for that is e to the minus 1, that's what x is, and that's what I want it to be. And then this up here would be 1. All right, then the next thing I notice is that the arctangent of x, and what's x is e to the u. Now, I got to do the dx now, and it's dx over x. So what's dx? Well, dx is e to the u du. And this is all over x, which is e to the u. Well, this seems like it got a little bit easier for me. Now, what I mean by looking at that, you know, the e to the u's cancel off, and I'm left with, you know, just arctangent of e to the u du. All right? Now, one thing I would do looking at that, I'd say, gee, that looks like a successful scenario over here, and I'm hoping that this is odd, but it's not odd. All right, it's not odd. In other words, I'm saying that if it's odd, you would have f of x equal the opposite of f of minus x. Let me just write down what I mean by that. And this is arctan of e to the u, that's what f of x is, by the way, but actually f of u would be the opposite of the arctangent of e to the minus u, and that's simply not true, by the way. So I'm going to say that's sort of, you know, at that point you might say, I'm very discouraged now, what are you going to do about that? And, you know, certainly I can understand stopping right there. I mean, you did something, you tried something, you stopped somewhere or something, but I want to keep going. I'm looking at this thing and saying, you know, it's not an odd function, so I got to go on. And what I'm going to try to use substitution again. And let me write that down for you. And what I'm going to try to do now, let me get this information erased and tell you what I'm concentrating on. So I'm going to erase this business over here. We're done with that. And we arrived at this level over here. By the way, I'm calling this integration A. So this I'm just going to call it A. Let's refer to it as A. And so what I'm going to do is another u substitution. And the u substitution now is u equals minus v. So I mean du equals minus dv. All right, relatively simple to do. And again, we're putting it over here. So what do you get? Well, let's take a look. We're in the land of u's. We want to go to v's. So this would be 1 to minus 1. And then you get the arctan. It's going to be e to the u. Well, that's going to be e to the minus v now. And the du is actually equal to minus dv. And if I look at that over there, I'm going to just, because I know it's minus, I'm going to switch the limits of integration now and say it's really the same thing as 1. I'm sorry, minus 1 to 1 arctangent of e to the minus v dv. And again, like somebody looking at it and say, is that really helping me? I don't know. You just keep moving forward. So we know what the a is. The a is this thing over here. That's what we came up with right over here. And now we got the a to be this thing over here now. Right, and they're identical statements, by the way. Then, I can understand getting stuck at any point, and I'm often, you know, kind of often impressed by how quickly students go through these problems here. They're given very limited time to go through them, and they do them quickly, by the way. I mean, I could not compete, right? So what I'm going to do is I'm going to say I'm kind of satisfied that we got to another level over here. I'm kind of looking at this over here. Whoops, sorry about that. I forgot to write something down over here. I'm sorry. I got to change something over here. I didn't realize that The notes will be reflective of the change though. Oh, you know what, I'm sorry, no, it's fine. This is equal to this over here, that's all I'm saying, by the way, there's nothing wrong with that, all right? So what am I saying over here? I'm saying that, minus 1 to 1 arctangent of e to the u du is the same thing as minus 1 to 1 arctangent e to the minus v dv. And I'm saying that's the same thing as the original integration, by the way. Now I'm in a loop, But I gotta be honest with these last two integrations I got, they're very similar. And I gotta think about this arctan function. And what I want to do is explain an identity that you may or may not know about. I want to go through that with you. And let me get my eraser out. I'm going to erase this business over here. And again, I'll go through one step at a time. Now, I do notice that, really well-prepared students, they don't need to derive things. They know these things like immediately. All right, so what I want to do is I want to go through it for you. And the way I'm going to do that is just simply look at this. I'm going to say arctangent. I would not consider this to be an identity that everyone would say, oh yeah, I know what that is. I'll just write down y. So that means the tangent of y is equal to 1 over x. I'm going to put a triangle down for you with an angle. It's a right triangle, by the way, with an angle y. And the tangent of y is going to be 1 over x. Now, this is a cofunction. I'm going to put the angle over here. And what would that be? It would be pi over 2 minus y. Now, let me write this down now. The tangent of pi over 2 minus y is equal to the opposite, which would be x. All right? It looks pretty easy. Let me keep doing that now and write this over here. So I'm going to write down pi over 2 minus y is equal to the arctangent of x. And again, I'm trying to derive that identity, by the way. And the question is, do I know what y is? I do. So it's really, this is pi over 2 minus the arctangent of 1 over x. That's what y is, by the way. And that equals the arctangent of x. All right? And again, someone says, what do you do there? I kind of rearrange it because I really want to solve for this thing over here. So I add that to both sides and subtract this from both sides, and you get this over here. And this is an important identity that some people know off the top of their head. And certainly I'm going to say I do know a lot of identities off the top of my head, but not that one. I'd have to think about that. All right? So I'm going to say that's known to me now. Let me erase this over here. And I feel comfortable with that. And what I'm going to do is, how does that apply to what we have over here? Let's just talk about what we left with. We were left over here, which again, this is A, and A is this thing over here. And let me repeat this over here. This is also A. We got everything is A, by the way. All right? So what I'm going to do is write this down for you. And I'm going to say A is, and again, we're talking about this guy over here. And then what I did was I just wrote that as, e to the minus v is 1 over e. And I got this identity over here. And what would that give me? Well, pi over 2 minus the arctan of e to the v. That's all I'm doing. I'm using that identity over there. What do I do now? I split this into two integrations, and I get this one over here, which is really, it's still A. All right, that's still A. All right? Now the question is, can I integrate that first guy? And I'll write this down for you. And I'm write down minus 1 to 1 pi over 2 dv. Right, what do you get over here? You get pi over 2 v, limit integration minus 1 to 1, pi over 2. This would be 1 minus a minus 1, which is 1 plus 1. And 2 times pi over 2 is just pi. All right? So this stands to reason. Then I get this thing over here. Again, we have to start to realize that, it's an A. So really we have pi minus A equals A. So I think right now I can figure out what A is by adding A to both sides. You get 2A is equal to pi. And what do you get over here? A equals pi over 2. All right? So what does this thing up here equal? It's a long road, but this thing over here is equal to pi over 2. Now, I'd be kind of curious if someone could, maybe come up with an answer drift and say, I don't think so, but who knows? Maybe someone has another trick that I'm not aware of that get that over there. So again, what's interesting about this over there, again, going back to this over here, that there's a whole group of students that participate in this, and I think it's in a couple of different places. Berkeley, California. I tried San Francisco. When I say Berkeley, it's the school Berkeley. I also believe it's offered in Canada, I think Toronto, and also in Asia. And again, these things are for high school and middle school students that are at this level of the game, by the way. Thank you.